Okay, on assessments, you have, I think, question number 29. I'm going to do question number 30 for you, which is very similar. So notice that this is what the book gives us as far as what we need to solve. What's the formula they want us to use? So y equals a times e raised to the power bx. And the first thing we need to do is we need to solve for a, and a is going to be the initial amount. Well, just like we did with radioactive isotopes. And if you haven't gotten to that problem yet, well, let me show you how to solve for a. Let's see what we have here. We know that when x is 0, y is 1/2. Well, when x is 0, that's actually helpful. So watch. 5 1/2 for y equals a times e raised to the power b times 0. Look at what that 0 does. So b times 0 is 0, so this whole thing is now 0, and anything raised to the 0 power is 1, so just e, not a times e, just e is raised to the 0 power, and e to the 0 power is 1. So that leaves me with 1/2 equals a times 1. So a equals 1/2. So that's a start. So let's go back now. Y equals 1/2. We're not done. We're just getting closer to the answer. 1/2 times e to the bx. So our job is to solve for b, but we have one less unknown now. So I'm going to use this other point, the 4 or 5. I'm going to use that to solve for b. So let's see, 5 is 4, so I'm going to substitute 5 for y. Not 5 is 4, 5 is y, I'm sorry. Equals 1/2 e raised to the b times x. X here is 4, so 4b raised to the 4b power. Okay, so if you look here, I only have one unknown. This is my only unknown. So I'm going to solve for it. Okay. Well, I'm going to divide. Again, don't start natural logging from the very beginning. You want to isolate b. You want to try and get everything around b out of the way first. And I can get rid of that 1/2. I can multiply both sides by 2 or divide by 1/2. It's the same thing. So if I multiply both sides by 2, now I have 10 equals e to the 4b power. Okay, now I have to natural log. But before we do that, let's apply the power rule. The power rule says that e to the 4b, actually, no, let's go ahead and natural log. We can't do the power rule. Sorry, we can't do the power rule until we apply natural log. I'm kind of a little ahead of myself here. Let me just undo this. So I want to be able to bring this exponent down, and that's why logarithms are so useful. So the natural log of 10, remember what we do to one side, we have to do to the other, equals the natural log of e to the 4b power. Okay, so the natural log of 10 equals, well, the natural log of e is 1, and here the power rule, I can bring this, and it's a coefficient. So equals 4b times the natural log of e, which is 1. I'm not going to write times 1. 4b times 1 is just 4b. Okay, so now I can solve for b, and b is just the natural log. Whoa, what happened there? The natural log of 10 divided by 4. On assessments, it's going to ask you to just to give you b. So let me just be clear. The final answer that the book is asking you to do is to give you the equation. I just want you, for just to make it easier, I just want b in assessment. So let's see here. The natural log of 10 divided by 4, and I have 0.57. Let me just see. I think I asked you to round to 2 decimal places. Let's see here. So I have 0.5756. If I were asking you to round to 3 decimal places, so here's the answer I have on my calculator, 0.5756. If I asked you to round to the nearest second decimal place, you would just write that b equals 0.58. If I asked you to round to the nearest third decimal place, then you would tell me the answer is 0.576. And I have however many decimals I want you to round in bold. The final answer, had I asked you on a quiz, if I ask you, well, what's the function is going to be y equals 1 half, where are we? 1 half e to the 0.576x. And that would be the final answer on a quiz, but on assessments, I just want you to give you B because that was the most involved step. Okay, I hope this helps. Bye bye.